Hi everyone, it is me, Miss Cram again, and I was reading through your comments on the last slide, and it seemed like this was a pretty good lesson for most of you, but the wording threw you off a little bit, and we'll talk about that. So this is what you did last Thursday and Friday, the 14th and 15th, and let's get started. All right. So the big new term is a function's end behavior. And that really just means when you look the furthest to the left, the furthest to the right, which direction is the graph going? Like, is it going one side is down and the other side's up? Is it both going up like a quadratic, both going down? But it's like that furthest amount of like on either side, like left or right, like is it going up, down, or a combination of an up and a down? All right. Oh, and let me move myself a little bit so I can go to the next slide. All right, so here, one of the big noticings was that this is what we call a cubic function, right? And I know that it's a cubic function, one, because I've got a degree of 3. So if the highest if the highest exponent is a 3, that is cubic, right? And we've got standard form, so I know that the first term, the leading term, is where I'm going to identify what type of function it is. Okay, when we come here, this is also a cubic graph, all right? So one of the reasons that I can tell it's a cubic graph is because I've got one side that is kind of ending here, right? Like where the y values are super negative. And then at this end, it's going upwards, right? So that kind of connection between the cubic function written out, that cubic equation, and how it looks on a graph is a big connection for this lesson. All right. By the way, this is a great video to watch. I hope all of you watched it on Thursday or Friday whenever you had Algebra 2. But if you didn't, then please go back and watch that. Here you can kind of see what is going on, that if you have a even degree, right? So here this is 2, right? Then you're going to start and end in the same direction, in this case up, right? So here I'm kind of like looking at it from left to right. So I'm starting up, I'm ending up. Here again, I've got that even degree. You probably can't see it, but it is negative, which is why it's upside down, x squared, right? Which is why it's ending in the same direction. So anytime you have an even exponent, you're going to be starting and ending in the same direction with your graph. And it's really just to start identifying, like if I said x to the 100th power, right? You know that no matter how many kind of like ups and downs it goes through, it is actually going to start and end in the same direction. So either they're both going to be up or they're both going to be down. And I know that because it's an even exponent. All right. Whereas in this case, we have x to, I believe that's the 3rd, right? So this odd degree, again, it like if it starts down here, it ends up here, right? If it starts up here, it ends down here. It's kind of going the opposite start and end, okay? And if I said x to the 59th, right? That's an odd exponent. If the 59 is the highest, then again, if I start up here, I don't care how many ups and downs I go, I know it will end down here, all right? So really keep that connection between the highest exponent of the leading coefficient and the end functions, right? How it ends on either side of the graph. All right, so here they did go over how to create a table in this video here. I'll quickly go over it, but a more thorough explanation will actually be in this video. All right, so to create any of them, right, including a table right here, I can click on the plus and then click on table. right? If I want to create a table specifically for this y equals x squared plus 1, I can replace this y, right, y1. I can just delete that, and I can replace it with what this y, right, the function I actually want to see, what that is equal to. So I might actually retype this so that I actually get, oh, okay, they actually have the exponent. Okay, cool. So this right here, too many variables, what's going on? I just need to come over to this side and delete that and just put x. All right. So I'm just going to go over here and say, okay, if x is, and I'm just going to pick a really uh, high negative, if that makes sense. So I think in the example that they gave, it was like negative 1,000. And the reason, I'm actually going to do just negative 100. The reason for that is because I want to know, okay, when x is super negative, what is the y value going to be? And you see here that it is a positive, what is that, 10,001? So when x is super negative, right, like somewhere way over here off the screen, then the y is going to be way up here. So I don't really care, like obviously that's not scaled correctly, but I do know that when x is super negative, my y value is going to be up here, okay? And then let me do a couple more. So let me just go negative 10. All right. And then it gives me, okay, positive 101. So yeah, so I know that at negative 10, I'll have like positive 101, right? So this will eventually make a parabola shape. And they go the other direction, and we'll find out. But when you have like positive 100, you're also going to be way up here. So the end function, right? I'm just going to like draw kind of like a horrible sketch for you guys. So it will be something like a U shape, which, okay, Ms. Krim is failing at this miserably. But the point is the ends, oops. Okay, the point is the ends start up and end up. All right. And a lot of you were talking about like the words in the next few slides, and they were just saying as x values get really, really big, which is a weird way of wording it, then the y values are really, really big in the positive direction. Okay. But we'll kind of look at that a little bit. So again, end functions are how you start and how you end, right? So let's just finish this really quickly. Go back to the graph, maybe. Okay, so let's just say 0. Okay, and then it's 1. Oh, I see that dot here, so you can tell my graph is super way off. And then I've got 10 and 1,000. Oh, yeah, let's just go here, right? So I can tell as the x's are getting really, really big in the positive direction, the y's are still way up here, all right? Okay, so they wanted you to create a table. Oh, they also wanted you to actually create a graph. So I'm going to delete my graph. Let's see if I can get rid of all this. Okay, and then I'm going to actually just graph it accurately. How about that? All right, so here we are. All right, I'm just going to take this, I'm going to copy it, I'm going to paste it. Cool. And there's the graph. As you see, the end functions are, it starts up and ends up. And that will be fine for any tests that we give you. Here, I can say this graph starts up and ends up. So that is the end behavior. And think back to the previous slide. If they both are the same direction, like they're both up, I know that the highest exponent will be an even number. All right. So let's go on to the next slide. Maybe we'll get some wording in here. Okay, this is exactly the same thing, except this is x to the third. So think about it in your head right now. what is the end behavior of this graph if it's x to the third? Okay, I am not going to create the table. You should be able to do that based on what we did in the last slide, but hopefully you have that end behavior in your head. Did it look like this? Right? So hopefully you could kind of tell that it would start down, end up, right? Or if not that it just has different directions. Okay? So this odd exponent should tell you, hey, it starts and ends in different directions. Okay? Okay, so this graph, let me say this cubic. Let me use my vocabulary. Graph starts up and, oops, not true, starts down and ends up. Okay, so that is my end function, just that noticing. And also connecting that, oh, the reason for that is this cubic, this odd exponent. Now, what if I changed it to a, I don't know, a 5? Right? So if you notice, it still starts down and it still ends up. Let me see if I can get any kind of squiggle in here. All right, let's see what happens if I do a 7. Oh, look, it looks pretty much right. So there are some differences, but the thing to really take away for this lesson, oops, okay. The thing to take away for this lesson is that they will have the same end behaviors. All right, I wonder what happens when I do this. X, interesting. Right, so sometimes I like to just play around with these, right? Oops, 1. Or what if I do -4? Cool. All right, so the really important thing to note is that no matter what I change this to, let's try 51. As long, ooh, that is really interesting. Okay, we're not going to get sidetracked by that. But the really interesting thing to note is, again, it has got the same exact end behavior. Okay, so in the previous slide, you graphed a degree 2 polynomial and a degree 3 polynomial. Which one is this graph closer to as far as end behavior? All right, so take a second, think about that. Okay, notice that this is an even exponent. So which of these is even, right? Here we go. And so it should have a very similar end behavior to an x squared. Okay, again, they do different things, right? It's not identical, but it does have the same end behavior where it starts up, ends up. Okay, same thing here. So x to the 5th, what's it gonna do? 3, 2. All right, hopefully you said something similar to an x to the 3rd graph where it starts down, ends up. Right, starts down, ends up. Okay, now if I were to put a negative in front of the leading coefficient, any idea what that would do? Let's try it. All right, so it just really flips the direction. So now it starts up, ends down. Okay, but either way, odd exponents for leading coefficients will have it starting and ending in different directions. Okay, so which of the following equations could be an equation for the graph? Well, I know it is ending and starting in the same direction. All right, so I'm thinking it's going to be an even exponent. So which one of these? All right, let's see. Okay, I got it. All right, so here I'm just going to do a quick distribution. I'm going to multiply these two binomials. So I've got x times x is x squared. Okay, x times 3 is a plus 3x. Oops. And now I'm going to multiply this, right? So I got this from these two. All right, I'm going to multiply this by my last factor, which is x. Oops, it's not x. It is a 2. All right, 2 minus x. All right, so I've got x squared times 2, 2x squared. 3x times 2 would be 6x. Okay, and now x squared times a negative x would be negative x to the third. And 3x times negative x would be negative 3x squared. Okay, so I'm not even interested in putting this in standard form. You know, you could, that's great. But what I'm interested in is the highest exponent, all right? And that's a 3. So that would not give us this. Remember, x to the third, it starts down here, ends up here. All right, so that would not be it. Here, I've got an even exponent. That could definitely work, all right? Here, let me just do this again real quick. 5 times x is 5x. Okay, and 5 times 3 is 15. And then this minus 5x is not in a parentheses. It's not being multiplied like it was in the first choice. So I can just put minus 5x here. Okay. So I've got 5x minus 5x. These actually cancel out to 0. 5x minus itself, 0. So here I just have 15, right? So I don't have any highest exponent, right? So so that would just be 15. If I were to, well, let me not even try and graph that. All right, and then the last one, again, I'm doing these two factors. X times x is x squared. Cool. X times 3 is 3x. Right, and I multiply that. Oh, that looks really similar to the first choice. So except instead of 2 minus x, this is 2 plus x. So I wonder if that will give me the same, I wonder if that will be an x to the third. Okay. Oh, and I forgot this is a negative x to the third. So I think, yeah, that would start up here and end down here. Okay. All right. So here we have x squared times 2. And just a side note, when I looked through the slides when you did multiplying binomials, it seems like this class is pretty on track. All right, so I have 3x plus, or 3x times 2 is a positive 6x, and 3x times x is a positive 3x squared. Okay, so again, I could combine the 3x squared and the 2x squared, but I'm really interested in this one. All right, so here I've got a positive x to the third. So again, they're going to be in different directions, right? So this could really only go with the second one. All right, so here I think we have maybe, yeah, I think we have the same answer options. So again, we start down here, we end up here. So the equation that could work for this one, right, would be, and let me just look at the work I did here, would be this x, this negative x to the third. Remember when you change it to a negative, right? It kind of flips it. So this would start up here and down here, okay? And I think that's what we have. Oh, wait. Nope, it's the reverse of that, sorry. So we start down here, end up here. So that would have to be the positive version, this last one. All right, so let's mark that. Okay, so let's see if they have another. I think that this is where we had some issues with, as the inputs, the x values get larger in either the positive or negative direction. So that means that if I have x and I have like negative 1 billion, or let me just put negative 100, I think that's far enough on the negative, and I have a positive 100, I think that's probably far enough on the positive. Will the y values get bigger and bigger? Will they continue going up and up and up? Or will they get smaller and smaller and smaller? Will they be both going down? Okay, so it's kind of like, what will the y values be doing? Will they be both positive? Would they be both negatives, right? They're going downwards. Would they have one of each? Right? Maybe it starts negative, ends positive. Okay, so kind of what would their end function be here? All right, note that if the graph is ending in the same direction, right, it's got to have an even degree for the leading coefficient. So play around with those things for a little bit. I get that the wording is tough. All right, so, but we're going to tackle the wording right now. All right, an even degree. So I've got to write an equation for a polynomial with the properties that they're giving me here. All right, so it needs to have an even degree. So I'm going to write y equals x to the 6. Oops, 65 is not. Okay, so it's even. Great. Has at least 2 terms. So remember, this is considered one term. I can put a coefficient in front of it, still one term. So if I want 2 terms, I need to either add or subtract something to that. All right, so I'm going to add 7x. Great. All right, so that's it. I think that's it. Wait, as the inputs get larger and larger in either direction, the negative or positive directions, in either the negative or positive directions, the outputs get larger and larger in the negative direction. Okay, so let me break that down. All right, as the inputs get larger and larger in the positive or negative directions, okay, so that means the inputs are your x values. So if I've got an x value, right, that's a big negative number, let me put negative 100, in either the negative or the positive direction. So big number, negative, sorry, it's late. Big number in the negative direction, negative 100. Big number in the positive direction, positive 100. Okay, I'm just picking those numbers because they're big. The outputs, or the y values, get larger and larger in the negative direction. So both of the y values are going to get larger and larger in the negative direction. I'm going to work on the wording of this so that it's a little bit more user-friendly. But they basically mean, okay, I get that it's even. These are going to be going in the same direction. The end functions mean that it's going to start and end in the same direction. And I want them both ending where the y is super negative, right? Does anyone remember how to do that? I'm going to tell you in 3, 2, right? Make that leading coefficient, right, for the leading term, make that into a negative number. right? So we went from positive 4x to the 6, both ending up, right? That was their end function, to negative 4x to the 6. So they're both ending down. All right, and then I just kind of follow that through the rest of the directions. So cool, I got all of that. And let's go to slide 14. Okay, again, as the inputs are the x values, get larger and larger in the negative direction. So the input, okay, so the x values get larger in the negative direction. Again, I'm just randomly picking a big negative number. And the outputs get larger and larger in the positive direction. So the outputs are the y values. Let me just put a little y here. Okay. And as the inputs get larger and larger in the positive direction, so positive 100, the outputs get larger and larger in the negative direction. Interesting. So I start up here, but I'm going to end, down here. Okay, with a better graph than that. But that's kind of, I'm just focused on the end function. All right. This will be an odd exponent. Will it be x to the third? Will it be x to the fifth? X to the 11th? That we don't care so much about. It just needs to be that the leading term has an odd exponent. All right, so same thing here, and we're gonna do this a little bit quicker. All right, so odd degree, at least two terms, okay? As the input, make a table here. As the input gets larger and larger in a negative direction, okay? As the inputs get larger and larger in the negative direction, the outputs get larger and larger in the positive direction. All right, so I'm just gonna put like, I don't know, let me put like 5. Great. I'm gonna try and see if I can get it to show up here. And oh well, no, that wouldn't show. It's negative 100. Sorry. All right, so whatever. All right, so it's a pretty large positive number. And as the inputs get larger and larger in the positive direction, okay, the outputs get larger and larger in the negative direction. Okay, so let's just, cool. All right, so if I just draw like a quick sketch of this, when x is super negative, I'm going to have a y in the positives, okay? When x is positive, I'm going to have a y in the negatives. And I'm just going to put it here because my camera's in the way. All right, so it would be something like this, right? Where I start up here and end up here. So let me graph and see what I can kind of come up with. And it needs at least, oh, that means 2 or more, right? So let's get back to this. I have y equals, I know it is going to be an odd, I forget, did they give me, yeah, just an odd degree. Okay, so let me say 5x to the, any odd number, right? 5. Keep the 5s. This coefficient could be any number. I could make that a 4, whatever. The important thing is that the exponent is odd. And I need at least 2, so let me say minus 3x plus 7. Cool. Oh, wait, let me move that down a little bit. Let me say plus 1. Okay, so I can kind of see it. All right, so this starts down. I want it to start up. All right, so again, I'm going to go to that lead coefficient and turn it into a negative. Now I start up and I end down. So the end functions match. I have an odd exponent and I have at least two, in this case, three terms. All right, so here's the end behavior, right? We're going to be talking about end behavior. The first thing you should notice is I've got an odd exponent and I've got a negative in front of the leading term. All right, so that should tell you I'm starting up here. I'm going to start up here, and then at some point I'm going to go down here. All right, so as x gets larger and larger in the negative direction, it's talking here, m of x gets larger and larger in the positive direction. All right, and as x gets larger and larger in the positive direction, right, so here's x's, right, it's getting larger and larger, it's going this way, then m of x will be getting larger and larger in the negative direction, it's going down. Right, again, I know that wording is a little confusing. We will try to make it better on any test or a little bit more user-friendly. Okay, this is very similar. So I'm not going to draw it out, but we have an even exponent. So that means it should be ending and starting same direction. Negative. So again, think of like a parabola that's positive is like a U shape. This one would be going downwards, right? So actually, I will draw it out. I always say I won't, and then I do anyways. Okay. All right. So it's facing downwards because of this negative. And it is going in the same direction because I have an even number exponent, right? So it's starting down, ending down. So when x gets larger and larger in the negative direction, so I'm kind of going this way, m of x would get larger and larger also in the negative direction because it is going downwards, all right? Same thing over here. As x gets larger and larger in the positive direction, m of x also gets larger and larger in the negative direction, again, because it is going downwards. Okay, so here's your lesson summary. We have reached the conclusion of Thursday, Friday's lesson. So hopefully these videos are helping you. Again, use your homework time because again, there's not an official homework that you need to do each night. So watching these videos, making sure you really understand the lesson. And I believe your first assessment is going to be at the end of this month. I think the 28th, 29th. We will let you know on Google Classroom or in class, but please make sure that you're keeping up and understanding the work that we're going through. And really great job, especially those of you that don't see me, don't see Miss Distelhorst. Really great job at, keeping up and doing your best. I really see a lot of you putting in effort, and I'm really proud of that. All right, well, have a wonderful day. Email me if you need anything, and I will see you later.